Hello friends, welcome to our channel. I hope you are all in a very good health and you are studying with your full focus. Thank you for joining me today. Today we are going to start the chapter Ratio and Proportion from the book Ganit Prakash of class 10. So we have some basic ideas of ratio and proportion because we have done it in our previous classes. But today I am going to give you a brief idea about ratio and proportion. So let us first understand what is a ratio. So we can say ratio is used for comparison when we compare two similar quantities. One quantity is how many times the other one quantity, or we can say the value of one quantity, the magnitude of one quantity is how many times the value of other similar quantity. This can be represented in the form of ratio. For example, we can say the ratio of father's age to son's age is 4:1. It means, okay, we read it this dot dot as is to. Okay, it means we if we consider the actual ages are not known, then this ratio simply signifies that father's age is 4 times that of son's age. Okay. Whatever the son's age is, we do not care about that. But father's age should be 4 times of the son's age. Or we can say it conversely, son's age will be one-fourth of father's age. Whatever the father's age is, we do not know, but son's age will be 4 times, sorry, one-fourth of the father's age. Okay, so this is what it means. Again, let me give another example. The ratio of water to sugar in a solution is 5:1, or we can say okay, 5:1. That means whatever the quantity of sugar is, we do not care. Or we can say it means the quantity of water is 5 times that of sugar. Okay. Now, if we say um, we can say 5/6 part of the solution for this example. Okay, we can say 5/6 part of the solution is water. Okay, so we are talking about water. So in so this position is for water, because water is first, after that sugar. So in the ratio, water comes first. So this is the position of water. Okay. So in the first position, in water's position, we are observing 5. So we have to write 5 in the numerator, and the total 5 plus 1 6 in the denominator. So this gives the fraction of water in that solution. Okay, we can also think it like this. We can say 5/6 part of the solution is water. Okay, and in sugar's position we are observing 1, that means 1/6 part of the solution is sugar. This is how we can write. Again, we can also convert it into percentage if we like. That means, so water is 5/6. That means if we convert it into percentage, then we can simply multiply it by 100%. Now it gives us 250 by 3%, which is equal to 83.33% approximately. And sugar equal to 1/6 into 100%. Sorry. 16.67% approximately. So we can also represent it in the form of percentage. Now, if the total solution is x unit, then how we are going to represent it? If the solution, if the total solution is x unit, it can be on liter or it can be on cc. Okay, so I am just writing unit. So if the total solution is x unit, then we can say, therefore water is equal to the fraction 5/6 into total. Okay, so the fraction of water, the part of water 5/6 into x unit. So this is 5x by 6 unit. This is our water. Similarly, sugar 1 by 6 into x unit, that means x by 6 unit. So this can also be a representation. Okay, if the total quantity is given, then we can represent it like this. So I hope all the formats are already known to you. Now, if a ratio is given, that means For example, 5 is to 3. Then if we want, you can open this, we can open this ratio. Okay, let us assume if a ratio is given. Okay, for example this. So let us assume this is water, and the second part represents syrup. Okay, then we can open this. That means water is 5x, or yes, water is 5x and syrup is 3x, where so we can open a ratio if we want by multiplying all the components of it by a fixed number. Okay, by a uh, specific number. Okay, where x is a positive number. Okay, if we want, we can open it. Now the number which is being multiplied to all the components of ratio, this number is actually x is actually the HCF of the first quantity and the second quantity. So we are actually multiplying it by their HCF. So the total, therefore, total quantity of mixture becomes 5x plus 3x. That means 8x. Okay. Now, if the total quantity of water is given, then we can equate that with 8x, and we can find the value of x. Okay. For example, we can say if the total quantity is given, for example, it is 1 28 cc. If the total quantity is given, we can equate these two quantities. Okay, that means 8x. I am just giving an example. This is how problems can be solved. Okay, so the total quantity can be determined by opening a ratio, and this quantity can be equal to this quantity. So x equal to 1 to 8 by 8. So this is a type of question that comes. Now ratio can also be represented in the form of one number divided by another. A ratio can also be denoted by the value of one quantity divided by the value of another quantity. That means in this case we have discussed 5 is to 3. So 5 is to 3 can also be written as 5 by 3. When we find a ratio of similar quantities, then the units gets cancelled. So a ratio has no unit. A ratio does not change if we multiply or divide or divide the a ratio does not change if we multiply or divide the numerator and denominator by the same number. That means A by B, if we multiply the numerator and denominator by K, the ratio remains same where K is not 0. Or if we want, we can divide this ratio. Okay, so from this to this and from this to this can be written A by K1 by B by K1, where K1 is a non-zero constant. Okay, so the value remains same. And when we look at a ratio of two terms, the first term is called antecedent and the second term is called consequent. Consequent, consequent. Okay. So when we multiply numerator and denominator by same constant, or divide numerator and denominator by same constant, the ratio does not change. Okay. So for a ratio, when the antecedent is equal to consequent, this kind of a ratio is called, so it becomes a by b equal to 1 by 1. This kind of ratio is called ratio of equality. So this is called ratio of equality. And if a by b is greater than 1, that means a is not equal to b. A is not equal to b, and a by b greater than 1, this kind of ratio is called the ratio of greater inequality. And okay, so this is the case when a not equal to b, and one more case can happen when a not equal to b, that is a by b is less than 1. Okay, so numerator and denominators are different, and in this case we are observing a by b is less than 1. This is called ratio of lesser inequality. So if a by b is a ratio, a by b is our ratio, and when we find out, okay, so this is our ratio, a is to b. So if we interchange the if we interchange the antecedent and consequent of the ratio, it gives us b is to a, that means b by a. So this is the reciprocal of the first ratio, or we can say inverse or reciprocal of the first ratio. When two different ratios are given, A is to B and C is to D, if we multiply the first term to the first term, that means antecedent to antecedent. If we multiply antecedent to antecedent and precedent to precedent, we get AC is to BD. When we multiply antecedent to the antecedent and consequent to the consequent, we get a new ratio. This is called the compound ratio.